Welcome back to class, everyone. I hope you all survived the exam and everyone's doing well. To kick us off, I'm going to explain how the next several weeks are going to work. The next two chapters that we're going to be covering are chapters 7 and 8. Both of those chapters are somewhat technical, and I don't want to just blow through them and leave everybody in a wake of confusion. So I'm going to slow down a little bit and give you these chapters in bite-sized pieces. So today is going to be part 1 of chapter 7, where chapter 7 will be a 3-part series. The name of chapter 7 is Demand for Insurance. And if you think about it, this will be the first time this semester we've really talked about insurance in any depth. So we're going to start with theory so you can understand why insurance is useful. The first thing to keep in mind as we think about the theoretical basis of insurance is that health is something that happens to us. The idea here is that there's some element of uncertainty with regard to our health. Some days I wake up and I just happen to be sick. I wasn't anticipating that, so there's uncertainty in terms of how I'm going to feel on a given day. What's true about the days that I happen to feel crummy is that sometimes I have to go to the doctor and take medicine. That's costly. So how much money I have is also going to be uncertain because my health is uncertain. Okay, buying insurance is a way for a person to eliminate some, if not all, of the money uncertainty in their life that stems from the uncertainty in their physical health. So succinctly, the way money uncertainty is reduced when you have insurance is that it takes out the volatility in your bank account. Yes, you're still going to have uncertainty with respect to your physical health, but if you get sick and you have insurance, then your bank account won't take such a big hit. The model we're going to use to demonstrate the usefulness of insurance is going to start with a utility function. In this model, note that utility is a function of only one thing, and that is income. So that means there's only one avenue through which utility can be affected, and that's income. If you want to change someone's utility, you have to do it by playing with their income. So in order to make our map or our model line up with the real world, we want the utility function to behave in a way that is consistent with how people feel when they get more income or less income. First of all, how do you feel when you get more income? Well, you feel happier. So this means that when income rises, we want utility to rise. How do we express this? We say that the first derivative of utility with respect to income is greater than 0. In other words, if we plot U against I, the slope will be positive. Okay, what else is true about how people feel when they get more income? Well, how much happier I am when you hand me $1 is dependent on how rich I am to begin with. So if you hand a homeless person $1, his utility is going to go up by a lot. On the other hand, if you hand Bill Gates $1, his utility will go up by just a little bit. And we can express this feature of people using the second derivative. Okay, think way back to high school days when you're taking calculus. Recall a second derivative captures how a slope is changing. So if handing a poor person $1 raises their utility by a lot, then for lower values of income, the slope will be very steep. But if we hand a really rich person $1 and it causes his utility to go up by just a little, then in ranges of income where income is large, the slope won't be quite so steep. So in other words, the magnitude of the positive slope will get smaller as income rises. This means that the second derivative will be less than 0. If you put it all together and say, okay, utility function, you have to have a positive first derivative and you also have to have a negative second derivative, then what you get graphically is a concave utility function. To drive home the point, what we've got in this model is utility that only depends on one thing, income, and we've imposed that more income must make a person happier, i.e. the first derivative of the utility function with respect to income is greater than 0. And we've also imposed that as you give a person more income, the happiness bounce for the person is larger when they're poorer than when they're richer, i.e. the second derivative of the utility function with respect to income is less than 0. Okay, the goal of this model is going to be to maximize utility. Again, we want to make a person as happy as we possibly can. But recall, we want to acknowledge that uncertain health leads to uncertain income. So utility is also going to be uncertain if we're uninsured and our bank accounts take a hit every time we wake up and happen to be sick. Okay, introduce gobs and gobs of notation. So just hang with me for a few minutes and hopefully this will help solidify everything in your minds. First, we're going to say that a person's probability of getting sick is P. And because there is uncertainty in terms of whether a person gets sick or not, we're going to say that P cannot equal 0. In that case, the person would know that they were not going to get sick. And similarly, P cannot equal 1, because in that case, the person would know that they were going to get sick for sure. So instead, P needs to be somewhere between 0 and 1, hence the parentheses around 0 and 1 as opposed to a set of brackets. So P can't touch 0 and it can't touch 1. It needs to be somewhere in the middle. So as an example, if P is equal to 0.25, that means that a person has a 25% probability of getting sick. If you have a 25% probability of getting sick, what is the probability you'll stay healthy? It's 75%. So given that, we can define 1 minus P as the probability of being healthy. Just note that the probability of getting sick and the probability of being healthy have to add up to 1. Or in other words, they have to add up to 100%. Okay, next thing, we're going to say that if a person gets sick, their income is going to be IS, and if a person stays healthy, their income is going to be IH. Okay, think for a minute about what you would expect in terms of the relative sizes of IS and IH. If your bank account takes a hit every time you get sick because you have to go buy medicine, then your sick income will be less than your healthy income. So because of this, we can say that IS will be less than IH. Recall, one of two things is going to happen to a person. Either they're going to get sick or they're going to stay healthy. If they get sick, they'll have an income of IS. And so what we could do is we could take this IS, we could plot it on our utility function and figure out how much utility a person would have if they got that sick income IS. Similarly, we could take the IH, we could plot it on the utility function, and the utility function would tell us how happy or how much utility the person would have if they realized the income level IH. But there's uncertainty, so the person doesn't know whether they'll land on the bottom dot, which corresponds to the lower level of utility and the lower income level, or the top dot, which corresponds to the higher utility level and the higher income level. Okay, here's where I'm going to have you use your imagination a little bit. Suppose there's this guy and he's trying to plan for his future. He doesn't know whether he'll be standing on dot A or dot B. His probability of landing on dot A will be P. His probability of landing on dot B will be 1 minus P. For the sake of argument, let's just suppose that this guy did have a P equal to 1, which we're going to disallow in the model, but let's just suppose it for the sake of a demonstration. If that was the case, he should expect to land on dot A because he has a 100% chance of being sick. But suppose that his P then fell a little bit. In that case, he should start walking towards dot B because there's a chance that he'll end up at dot B. And the bigger the chance is that he ends up at dot B, the more he should start walking towards dot B. So where he is on the road between A and B is synonymous with his expectation. Mathematically, expectations are calculated using expected values, and expected values are informed by probabilities. So a person's expected income is going to be EI equals P times IS plus 1 minus P times IH. In plain English, what is this? It's the guy's probability of getting sick times his income if he gets sick, plus his probability of being healthy times his income if he is healthy. It's a weighted average where the weight that you put on IS, or in other words, dot A, is based on the probability of having an income IS, or the probability of landing on dot A. So if P were equal to 1, then the expected income would be equal to IS. But as the probability of getting sick starts to fall, in other words, as the chance of getting IH starts to rise, then if you think back to the picture of the guy walking between the dots, then the guy will start walking along the path up towards the other dot, and the horizontal distance of his location, that's going to be the same as his expected income, which again depends on his probability of getting sick. So it's just how much relatively closer he is to dot A than to dot B. Okay, he doesn't end his journey at this midpoint location. So it's either going to happen is the guy's going to end his journey at dot A or dot B. In other words, at the end of the day, he either realizes the sick income or the healthy income, depending on what happens to his health. But initially, he doesn't know what's going to happen to his health. So he is just going to nudge himself closer or further away from one dot or the other, depending on what his probability of landing on either dot is. This means that a similar intuition holds for expected utility. At the end of the day, the guy will either get the utility level that goes with the sick income level, or he'll get the utility level that goes with the healthy income level. But he's going to journey along the path between the dots, depending on which dot he kind of has a higher probability of landing on. So his expected utility as he journeys between the dots is going to be his vertical distance when you look at where he is along the path. Mathematically, expected utility is going to be equal to EUI equals P times the utility that you get when you have the sick income plus 1 minus P times the utility you get when you have the healthy income. Okay, again, the person won't end up with the intermediate level of expected utility. Either they'll get the high or the low level of utility. But as the guy journeys along the path between the dots, the expected utility tells you how much relatively closer he is to UIS compared to UIH. Okay, let's just practice a little bit to see how the gears turn. I'm going to give you some questions and walk you through the answers. And then in the exercise period, you can kind of go loose and do these on your own. But for the lecture, I just want to kind of walk you through a couple of things to drive home a couple of points. Okay, first question. What does a high P mean? Answer, it means that a person has a high probability of getting sick. In other words, there's a high probability their income will be IS. There's also a high probability that their utility will be the lower level, UIS. Question 2, what happens to 1 minus P as P goes up? Answer, it goes down. Because, again, P and 1 minus P are inversely related. As one goes up, the other goes down, and vice versa. Now for question 3, suppose IS is equal to 100 and IH is equal to 200, and we're looking at a person who has a 90% chance of getting sick, so P equals 0.9. The question is, what is expected income? Here you can just plug things into the equation. So what you would get is EI equals 0.9 times 100 plus 0.1 times 200. This yields $110. That's like the horizontal location of a guy who's journeying between an income level of 100 and 200 with a 90% chance of landing on 100. Let's keep these same numbers. So IS is still 100, IH is still 200, P is still 0.9. The next question is, would the person who has these numbers actually get an income of $110? The answer is no. He doesn't realize the expected income. He'll either get $100 or he'll get $200. Okay, now let's think a little bit more deeply about how the gears turn. The next question is, in a general sense, what happens to expected income as P increases? The answer is that it falls. The reason is because as P increases, the person becomes more likely to get sick or more likely to end up on the lower dot. So as they're journeying, they're going to start walking towards the lower dot. And as they start walking that direction, their horizontal location moves left. In other words, their expected income falls. Okay, next question. What happens to expected utility as P increases? The answer is that it would also fall, because as the guy starts walking towards the lower dot, his vertical location on the graph also falls, and his vertical location in the journeying line goes with his expected utility. Okay, to really beat this horse to death, let's put the car in reverse and think about everything in the opposite direction. The next question is, what would happen to expected income as P falls? The answer is that now it would go up, because if P falls, that means the person is less likely to get sick. In other words, they're more likely to stay healthy, they're more likely to end up at dot B, so they're going to start walking towards that upper dot, and their horizontal location is going to move right. Final question, what would happen to expected utility as P falls? The answer is that it would increase, because again, as the guy starts walking towards the top dot, his vertical location is going to rise. All right, hopefully your brain is not sweating too badly at this point. If this is confusing, or if you have specific questions about any of this, chime in the next 10 minutes and I'll try to answer questions. And after that, we will meet back for the exercise. For the exercise today, I'm going to have you think about expected income and expected utility from a slightly different angle. So suppose there's a person who lives multiple time periods. So for instance, suppose there are 4 time periods in a person's life. And in each period, either they get sick or they stay healthy. So let's say that we're going to set things up such that if a person gets sick, their income is $0. In other words, IS equals 0. And if a person stays healthy, then in periods of their life when they're healthy, their income will be $10. So in other words, IH is equal to 10. Suppose if you make an income of $0, your utility is 0. So this would mean UIS is 0. And then let's also suppose if you make an income of $10, your utility is 1. So UIH would be 1. Okay, let's have a person who has a 25% probability of getting sick in any one period. And in each period, they either get sick or they stay healthy. Well, what we would expect in that setup is that for this person who lives for 4 time periods, if they have a 25% chance of getting sick in any one given time period, then we would expect that in one of their 4 time periods, they would get sick and they would have an income of $0 and they would have a utility of 0. And then in 3 out of the 4 periods of their life, we would expect them to have an income of $10 because they have a 75% chance of staying healthy. So let's just say what we would kind of anticipate is that for 75% of their life or 3 periods, they're going to be healthy. And so in those 3 periods where health is realized, income would be $10 in each of those periods, and accordingly, utility in each of those periods would be 1. Okay, the first question is, think about this person. Across the 4 periods of their life, what was their average income? Next question is for the same person. Across the 4 periods of their life, what was their average utility? Number 3, I want you to calculate the value for this person's expected income given the numbers above, where you're specifically looking at IS, IH, and P. Fourth question is I want you to calculate the value for this person's expected utility given the numbers above, where you're specifically looking at their utility under the sick income level, their utility under the healthy income level, and their P. Next question is just yes or no. And the question is, in any period of their life, did the person actually realize the expected income that you calculated? And the final question is, in any period of the person's life, did they actually realize the expected utility that you calculated? So for the last 2 questions, again, it's just a yes or no that you need to respond with. Once you have those questions answered, that is it for the day. Again, make sure you're reading the textbook. I know reading the textbook is not a fun activity, but it's going to be especially helpful in this chapter. So I hope everyone has a good rest of the day, and I will talk to you next class.